Welcome to lecture number 56, and we have been discussing with Tellegen's theorem. Very interesting theorem, Tellegen's theorem. And in my last class I told it is applicable only to different networks, but having same topology, And in this network 6 elements, elements are different, it is like that. Then about one thing I am certain, suppose I forget about the second network, which are this is suppose network A and this is network B, where all the quantities I have marked with primes. Now, in this network, at least this thing I know, if I calculate total power absorbed by each element and sum them up, that must be equal to 0. Now, what is the power absorbed? Sum of power absorbed by each element must be 0. What is that? Power absorbed by element 1, V 1, I 1. So, the plus current is entering. Is element 2 absorbing power based on the voltage polarity and the current direction? Yes, it absorbs. So, plus V 2 I 2. What the element 3 is doing? It is also absorbing power. So, it will be V 3 into I 3. What is element 4 doing? Absorbing, plus V 4 I 4. Element 5 absorbing, plus V 5 I 5. And element 6, okay, it is also absorbing, V 6 I 6, and this must be equal to 0, that is what we have learned. Similarly, in this network separately, only thing these numbers have been replaced by prime. Therefore, if you say I will use for network B, it will be similar equation will be V 1 dashed I 1 dashed, absorbing power, all the elements are, that is how I have assigned the directions, plus V 2 I 2 dashed plus V 3 I 3 dashed plus V 4 I 4 dashed. V 3 dashed, V 2 dashed, V 4 dashed plus V 5 dashed, I 5 dashed plus V 6 dashed, I 6 dashed. That will be also 0, why not? Separate network. So, this is the power balance equation for each of the networks, and nothing surprising about this. But now, Tellegen's theorem states that if you multiply voltages of network K with corresponding currents in those elements in network B, that is what I will do. Tellegen's theorem, this is not Tellegen's theorem, it is known, total power absorbed will be 0. Tellegen's theorem tells that you take voltage of this network, let us use different color. Say you take this color. Voltage of this network across element 1 multiply with current I 1 dashed, same element number 1 of the second network, plus voltage of this network across element 2, that is V 2, I will not multiply with I 2, but will multiply with I 2 dashed, and so on, B 3 I 3 dashed plus V 4 I 4 dashed plus V 5 I 5 dashed plus V 6 I 6 dashed. And Tellegen's theorem tells that these two will be equal to 0. Alternatively, you take the voltage of this network and multiply with the current of network K, then also it will be 0. What does this mean? Also, V 1 dashed into I 1, that is voltage across each element of network B multiplied by the corresponding currents of network K and sum them up. So, V 1 dashed into I 1 plus V 2 dashed into I 2 plus V 3 dashed into I 3 plus V 4 dashed into I 4 plus V 5 dashed into I 5 plus V 6 dashed into I 6, that will be also equal to 0. That is the new thing. The above two equations are okay, individually we know for each network it is. It looks surprising, voltage of one circuit multiplied with current of another circuit, these two has got no coupling, etc. How this happens, but that is what Tellegen's proposed, that this has to happen. And we will try to prove it. Proof is very simple and elementary, nothing complex, but the statement of the theorem you have understood. Therefore, two networks having same topology has to individually satisfy their own power balance equation, that was known. But in addition to that, these two lines, these two equations are also true. This is the Tellegen's theorem. Now, we will try to see how this can be proved. Why such a thing which is not so apparent, why voltage of this circuit and current in some other circuit, even if their topologies are same, why you multiply and sum them up will give you 0. How do you say that? It must be told that this V 1 and I 1 dash, for example, V 1 into I 1, I know specifically it has got a physical meaning. What it is? Amount of power absorbed by the load. But so far as V 1 into I 1 dash is concerned, we cannot assign any physical significance to that, because voltage of across element 1 of this network and current of network B, you are multiplying, what does it physically signify? We do not know, it is not possible to signify anything to this product. Although V 1 I 1 and V 1 dash I 1 dash, I know pretty well what they signify. But let us come to this result, why it will be like that. So, I go to next page and paste it once again. So, this is the thing. So, proof of this network I am trying to do. So, this is this network. Okay. The only thing, this has not been copied, this number was node A, this is node B, this is node C and this is node A, all things have come correctly. Acha. Now, from whatever network, and so this is proof of Tellegen's theorem. Now, it is done like this. Suppose I calculate the power here, that is I calculate V 1 I 1 of this network, V 1 I 1 all are absorbed V 2 I 2 plus V 3 I 3 plus V 4 I 4 plus V 5 I 5 plus V 6 I 6, is not. Now, this V 1 or this V 1 can be written as V A 0 minus V B 0, potential this V 1 is V A 0 minus V B 0, V A 0 minus V B 0 into I 1, this I can write, plus V 2 voltage across this element 2 is V A 0 itself, V A 0 minus V 0 0, that is 0. So, V A 0 I 2. For element 3, it will be simply V B 0 is equal to V 3 0. So, V B 0 into I 3. For element 4, it is plus V C 0 into I 4, and for element 5, it will be V A 0. Direction of current I have assumed like this. So, V A 0 minus V C 0 is the voltage which will make this side plus this side minus into I 5, and finally, the voltage across this element 6 is V B 0 minus V C 0 into I 6, this will be the thing. And this I know is certain to be 0, because power absorbed by all the elements in this network A, in network A. This is the thing. Now, what I will do is this, I will collect the terms of V A 0, V B 0, V C 0 separately. So, I can say that V A 0 into, from this term it will come I 1 plus I 2, this term V A 0, no V A 0 here, here also there, plus I 5 and no other V A 0. This will be the thing I can write, plus V B 0 similarly I will calculate V B 0. V B 0 is minus I 1, this will give minus I 1, this will give plus I 3, V B 0, V B 0 is here once again plus I 6, this will be the V B 0. Then what is V C 0? All the terms V C 0 I am collecting. No V C 0 here, no V C 0, no V C, it is I 4, I 4. Here minus I 5, minus I 5, and oh sorry, then another term is there, minus I 6 and that must be equal to 0, that is what I am telling. You see, I have calculated the power across each element and expressed the same quantity in terms of node voltages and some of the currents. Now, you see, or I 1 plus I 2 plus I 5, I 1 plus I 2 plus I 5 at junction A must be 0. This is KCL at A, is not? Similarly, I 3 plus I 6 minus I 1 at node B, you see I 3 plus I 6 is equal to minus I 1. So, here I write KCL this side only for this, KCL at node A, what it will be? I 1, all currents are coming out from the node, I 1 plus I 2 plus I 5, this must be equal to 0. KCL at node B, what is there? node B I3 plus I6 going out. So, I3 plus I6 and I1 is coming out, coming in. So, minus I1, this must be 0, that is I3 plus I6 is I1. So, I3 plus I6 minus I1 must be 0, and at node C, it will be I5 is converging at C, I3. So, I5 plus I6 and another minus I4 is also coming, minus I4, that is equal to 0. Is not? Which of course mean this is, if you take this to other sides, I4 minus I5 minus I6 is equal to 0, same thing. Therefore, you see this is KCL at A. Similarly, this term is KCL at node B, and this term is nothing but KCL at node 3. So, what I am telling is, suppose you have not, this is another way of proving that power balance. Suppose I am just calculating how much total power absorbed, no equal to 0 I have put. I know it has to be 0, this is one way of proving. Okay. In terms of node voltage you express, and then you say V A 0 into 0 plus V B 0 into 0 plus V C 0 into 0, and this must be equal to 0. That is what the power balance equation is. So, the total power absorbed by all the elements has to be 0, and it has come out to be 0, and this only thing I have expressed in terms of node voltages, that is all. Now, come to this network. In this network, everything is like this. Therefore, no point in going on writing V 1 dash I 1 dash plus V 2 dash I 2 dash. What I am telling, in network B, which is totally a separate network, network B, only thing, all the quantities here has been replaced by primes. So, same thing you will get if you apply, only thing they will become prime, that is I 1 dashed plus I 2 dashed plus I 5 dashed, then plus B 0 dashed into minus I 1 dashed plus I 3 dashed plus I C dashed, and plus B C 0 dashed into I 4 dashed minus I 5 dashed minus I 6 dashed. And once again I 1 dashed plus I 2 dashed plus I 5 dashed will be KCL at A dashed, at node A dashed. This is KCL at B dashed, and this is KCL, this must be at C dashed, node number C dashed. So, this will be once again 0, B A 0 into 0. So, these are all zeros, these terms, bracketed terms are zeros. So, this will be also equal to 0, that is separately the power balance will take place, is not? That is the whole idea. Now we are just at the last line of proving this. What is that? Now I am telling that, okay, let me do elaborately. Go to the next page and paste this one, move it. Okay. Now, come to this circuit once again. Now, what I will be doing is this, as suggested by Tellegen, that now let us try to calculate V 1 and then I 1 dashed. Voltage across this element and current in this element, plus power absorbed, all the things, plus V 2 voltage across this and current in second element of network B. This is network A, this is network B, plus V 3 into I 3 dashed, plus V 4 into I 4 dashed, plus V 5 into I 5 dashed, and plus V 6 into I 6 dashed. This is the thing. Here once again I will do the same thing, that is V 1, this voltage is of course equal to V A 0. Let me write that, okay, minus V B 0 into I 1 dashed. V 2, V 2 is nothing but V, this is A, mind you, V A 0 plus V A 0 into I 2 dashed. What is V 3? V B 0 into I 3 dashed, plus what is V 4, voltage across element 4, is nothing but V C 0, V C 0 into I 4 dashed. What is V 5? V A 0 minus V C 0 I 5, and finally across this element 6, V 6 is V B 0 minus V C 0, V B 0 minus V C 0. This will be the thing into I 6. And once again I collect the terms of V A 0. So, just out of curiosity I have multiplied without knowing really what does it physically imply. I have taken the voltage across element 1 and multiplied with I 1 dashed of circuit B and so on, just out of curiosity I am doing. And then I collect the term of V A 0. What I will be left with? I 1 dashed, this is plus I 2 dashed, this I 2 dashed will come, and V A 0 where else? Plus I 5 dashed. Then for V B 0 plus V B 0, if you collect, it is minus I 1 dashed from this, then plus I 3 dashed from this term, and plus I 6 dashed, and finally V C 0 into all the terms of V C 0, that is I 4 dashed from this place, minus I 5 dashed from this, and minus I 6 dashed, this one. Now, what is KCL at A? KCL in network B at A dashed is how much? I 1 dashed plus I 2 dashed plus I 5 dashed is 0. KCL at node B dashed is I 3 dashed plus I 6 dashed minus I 1 dashed, and that is equal to 0. And KCL at node C, KCL at C dashed will be how much? I 4 dashed minus I 5 dashed minus I 6 dashed is equal to 0. Therefore, this sum is equal to V A 0 into 0 plus V B 0 into 0 plus B C 0 into 0, and this has to be 0. This is the most interesting part. See, this B A 0 into now KCL of nodes. See, no matter these two circuits are independent. I1, I2, I3, I4, I5, I6 will be totally different from I1 dash, I2 dash, I3 dash, I4 dash, I5 dash and I6 dash. But I1 dash, I2 dash and I5 dash when added must be 0, because it is the compulsion of this network to satisfy KCL at all the points, at all the nodes A dashed, B dashed and C dashed. So, V A 0 is multiplied with a term which is KCL at nodes A dashed, B dashed, C dashed, and they are 0. That is why we say that, and we started with this and then came to this to establish that this indeed is 0. I am not going to elaborate it, but you can easily see. Similarly, V 1 dashed, if you wish to calculate, you can calculate, and I 1 I will do. Okay. So, let me go to, so understood this? This is Tellegen's theorem, voltage across this element, current in other, sum them up, then also it is 0. Similarly, I could do which is just a few lines I will write because it is necessary. Also this is network B, this is network A. Also note that V 1 dashed into I 1 I will do plus V 2 dashed voltages of this networks multiplied by the respective current in the first network, that is network A, actual current I 2 plus V 3 dashed plus I 3 plus V 4 dashed I 4 plus V 5 dashed I 5 plus V 6 dashed I 6. What this comes out to be? Okay, same procedure. V 1 dashed is what? Voltage across this element in terms of the node voltages V dashed A 0 minus V dashed B 0. I am sorry, I should write it much more correctly. B A dash 0 dashed, this is, this dashed will come A dashed 0 minus B did B dashed A dash 0 dashed into I 1 plus B 2 dashed is nothing but B 2 dashed is this one, B A dashed 0 dashed into I 2, this is I 1 plus element 3 B element 1 element correctly written, element 2 is B A dash 0 I 2, element 3 is B B dash 0 into I 3 B dash 0 dashed plus element 4 it is B C dashed 0 dashed into I 4, element 5 B dashed B A dash 0 dashed, I am always making mistake, B A dash 0 dashed minus element 5 B C dash 0 dashed, and that will be into I 5 current of this circuit, and finally the last term, that is, that will be plus, that is element 6 which is B B dashed 0 dashed minus B C dashed 0 dashed into I6 dash I6, and once again you collect the terms, that is B A dashed 0 dashed. It is equal to I1, from this I1 will come, then plus I5, from this it will come, and where is and plus I2, sorry, plus I2 also. So, let me put this 2 comes first, I2 plus I5. Similarly, B dashed O dashed will be equal to minus I1 from this, plus I3 from this, and plus I6, and finally, B C dashed 0 dashed will come as B dashed 0 dash C. C is not there, here it is I4 minus I5 and minus I6. But what is this thing? I1 plus I2 plus I5 is KCL of network at node A, this is A, B, C, and this must be 0. This one I1 plus I3 is nothing but KCL at node B of network A, not B dashed node. But this must be 0, this network whatever it is separate, but it is satisfying KCL at all the node I1 plus I3 plus I6, if hopefully it is coming correctly, and finally this one is nothing but KCL at node C of network A. These are all of network A, of network A. So, this in general is your Tellegen theorem. Okay. One interesting point is that see, okay, it is nothing but because KCL is satisfied, that is why you get this. We will see its application next class, but another interesting thing is the voltage across each elements of this network, that is V1 I1 dash. Suppose these two circuits are having current bearing voltages and currents, suppose time dependent thing. It is also to be noted that you take the voltages of this network at say some time, say T1, all the voltages I have taken, and the current values of this network I will take at some different times, say T2, still this will hold, simply because KCL is satisfied at all the times, no matter that it is satisfying now and then it is not satisfying, not like that. In fact, we have pointed this out many a times while going. KVL and KCL will be satisfied at all times in a circuit, be it linear circuit, nonlinear circuit, whatever it is, KCL has to satisfy, KVL has to satisfy. There are many applications in communication signal processing of this particular theorem, but we will apply here this theorem in our next class to establish another interesting circuit theorems called reciprocity theorem. Thank you. I stop here today, but go through this carefully. It is very interesting, otherwise two totally different circuit, but only point is they must be of same topology, then you cannot do. You cannot have a circuit like this with triangular topology with a circuit like that. This circuit is different topology, is not? You cannot, I mean perhaps another element you bring in. you must see structurally they are same type. Thank you.